today's lightning section. If you observe in the post we made about this section, we already had the part 1 of the section, and the link was attached to that post. So just in case you've not visited that, you can maybe go back to the post or probably search on Prince. Is it Praise? Okay, I think it's Praise. That Prince or Praise, yeah. That took the part 1 section on our YouTube channel. Then you can as well look into that so you will not be confused, or peradventure you are confused in course of the part 2, you can revisit that. So today I will be hosting my co-partner. He's my boss. So his name is Engineer Gbenga Joseph, yeah. And then he'll be walking us through Kafka part 2 tonight. I just said, okay, sorry, Samuel. All right. So please, let's kindly react with our favorite emoji as Samuel take over the floor for the next 1 hour. Yeah. Samuel, you can have it's just Rose and I want you guys sending emoji just in case other persons are asking questions. So you know those that are celebrating you. Samuel, are you ready?
Yeah, good evening, everyone. Good evening, everyone. Am I audible?
Sure.
Yeah. Okay. Okay. Disclaimer, I'm not a boss. She's my boss. If you've worked under Glory, you know what's the definition of pressure. So today I'll be taking us on Apache Kafka part 2. So I just dropped the link to the part 1. When I said part 2, it was confusing because they said, where's the part 1? Yeah, we've done the part 1, and it was, in fact, I went through the first part to actually pick this particular session. I get to actually come up with this idea. While Promise Akene, it's not Prosper, please, it's Promise Akene. Okay. So when he was taking the session, he wasn't explicit on Kafka, but we knew he was talking about pub sub pattern. Yet dealt several blows there. He touched on some important pattern. He even gave examples of how the implementation goes. He said there's the simple and then there's the complex pattern. Yet, and he also mentioned his own. And I think his argument was that the argument was that the system decides when the customer can subscribe. Why can't the client on their side unsubscribe from it? Like, why can't they choose to subscribe and don't subscribe? Okay, so that's where one of the arguments we brought out during that session. So let me continue with my talks as a build-up. If you understand from that part 1, you'll be able to follow through. I'll touch some practicals. Yeah, I'll touch some practicals. Just a little bit. Publish and subscribe. Publish and catch a message. Okay. So, but because I'm too stressed, the codes are already written. I'll just explain through the codes, please. Emabino, no vex. Okay, so let me go. So Apache Kafka builds for microservice, a distributed event streaming platform for scalable, fault-tolerant, high throughput architecture. Who am I? As you can see, That's name the picture. All right. That's how I feel some days. And this is how I'm feeling right now. Who am I? Fun fact, there's a movie, Who Am I? And yeah, this me looking at you here acted it. So I hope you are comfortable with Who Am I? No questions asked. Thank you very much. Why Kafka for microservice? Why Kafka for microservices? Now, decoupling, scalability, durability, asynchronous communication. Now, I want to reiterate an example that I promise I can give during this presentation. Why Kafka for microservice? And that just summarizes the whole mechanics behind Kafka. Now, Kafka is not the only tools for pub and sub architecture. So this is where I would try to like bring something in like into perspective. Let's say a certain kind of view. Yes, so they have RabbitMQ. Yes. Now, because if you see both of them in the pub sub pattern kind of structure, you might miss the intricate part of Kafka. Yeah. There's the difference in mechanism, the way Kafka and RabbitMQ actually works. So let me just talk about let me just give that example before I touched into decoupling, scalability, durability, asynchronous. So Promise gave a story. He said there was a time somebody, the mother's friend came to visit the mother. So, but the mother was not at home. So the mother dropped a message with Promise. So Promise being himself, he said he was very playful at that particular point, so he knows he's very forgetful of things. So what he did was to relay the message to his younger sister. So in case he forgets, the younger sister will still be able to deliver the message. So when the mother came back, she got the message. She got the message either from him or the younger sister. Yeah. So that concept actually shows us a very good view of what Kafka does, even different from RabbitMQ. Yes, that's decoupling in nature. You get the friend that came to visit the mother now, she does not have to care whether the mother is around. She has dropped a message. Decoupling. She does not need to care whether the mother is around. She's confident and has an assurance that she has dropped a message. And on the middle side and the decoupling flow, to make sure she gets the message, the broker it into partitions. Let's call it a replica. Yeah, Kafka will get to that part. Promise did replica. He replicated that message into another person. Let me use person. And then even if Promise fail, the replica will pick it up from there. So the Kafka in itself is a robust mechanism. It doesn't care in a way that we think in the pub and sex pattern. No, I think I'm from my own perspective. People might have a different perspective. I would say Kafka does not care in the sense of pub and sub patterns. In fact, it takes a different approach. But what Kafka really does care is that whoever I'm sending this message to gets it. It's even overly concerned about the consumer more than RabbitMQ. If you have used RabbitMQ before, it's concerned that the consumer gets the message or is able to pick up the message as it flows. So decoupling, that's a decoupled system now. The coupled system A does not need to care, system B is alive. Just give it to an intermediary, and then the intermediary is sorted. And Kafka is a very good intermediary. Okay, so scalability. Horizontal scaling across multiple machines. Now, you know what horizontal scaling is? You add more machines to what is already there. Yes, that's how you scale horizontal. You add more physical machines. Now, don't, because you might think that adding partitions to a single broker make it scale horizontally. No, it's not equal to horizontal scaling. No, yeah, as long as you are not adding more broker, you are not scaling horizontally. Yes, except you are adding more brokers, which is like more physical memories. Yes, if you are not doing that, partitioning is not horizontal scaling. Yes, you need the more broker for your partition to actually be horizontal scale when you are dealing with Kafka. Yes. So because the thing is the same power that we consume for, let's say, one partition on one broker will still be the same as consumed for 5 partitions. You get, just because it's just same one powerhouse. Let's put it that way. So then it's durable when it comes to message stored. You get replace message and other stuff. Kafka is a wonderful tool, and I really, when you think of how Kafka work, you really appreciate those that have contributed to this project. I'll show you if you work with it. So async comes, then no blocking between services, producers, files. It is this interesting part. Yes, producers fires and forget, and consumers processing at their place. Yes. So that's producer fires and forget. You need to when you are building, you need to handle that particular point gracefully. But Kafka is not handling that for you. Yes. Your producer part, Kafka is really not. And in fact, if your Kafka is down, your producer implementation will based on how you configure it, will not break your code. Will not break your, but on the consumer side, based on how you implement it, it will break your code. And if there's something that you rely on at a particular event, you actually want it to break the code so that you don't miss event, so that you know there's actually an issue, then you resolve it. But on the producer side, the producer event can be fine. You get even if Kafka is down. You get, so you undo your producer part yourself, so you don't lose data. Yes, there are different patterns on how to take care of that. But I'm not sure we are not going to pause that. I just want to remain on this, on the front side, and then just do some basic coding. Okay, are we together? Please confirm you can hear me. Hope so my network never deceive me. Hello, please confirm. Let me check.
Yeah, we can hear you.
Okay, thank you. Okay, okay. Pub submodel. Now, let me put it this way. Let me explain what might have registered in our head for pub submodel. That I publish, and there is a subscriber somewhere that receives it. You get, I publish, subscriber. What does subscribe mean? I subscribe. In fact, it will give you if you work with WebSockets, because I work with WebSockets. That's why I got the idea of pub submodel. Yes. Yeah. As long as I'm subscribed to a channel, like when this radio station, there's 106.5 FM. I think that's Wazobia. Is it Wazobia? So if you tune to that particular channel, whatever Wazobia is saying on their end, you will get it. You don't need to go to Wazobia to go and get that. As long as you are subscribed to that channel, you'll get that. You get that, whatever it is you're saying, as long as you're subscribed to the channel. You get. But Kafka does not align with that particular format. Kafka does not align with that particular format. Let me show. I think my okay. Let me share. Tell this tab instead. Can we see this screen? Hello. Let me show. Can we see my screen? I'll switch my screen. I just want to confirm
Yeah.
that.
Yes.
Okay,
Yeah,
thank
we
you.
can.
Very good. So how I visualize Kafka, I mean, you can visualize it differently, but how it helped me understand it is Kafka is a large bucket, like large, on very large buckets, very large buckets. Let's put it this way. Large buckets. Now we're putting things into this bucket. So it's a large bucket of streams of events, So events streams into it, 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 streams into it. So I was speaking to somebody and the person was confusing it with actually streams of video. Now you can do that, but it's very large, so it's not recommended. But there's just streams of events. I use this example. You see the way when you are running your application, the logs on your at the bottom tab in your console, you get the logs of that's streams of events happening in your in your um in your code, like running as your code is running. So those are streams of events being logged. So it's just a large bucket of logs. But instead of logs, it stores it in bytes. Actually, bytes. It's bytes. So you can call it streams of bytes. But we use streams of events. So it's just streams of events, streams of events, streams of events. So let me how do I use this stuff? See, yeah. So now inside of this Kafka, there is the producer that comes and poop. This is the producer. Let's call this Mr. P. Mr. P poops into it. And then there's the Mr. C that comes into the bucket and picks what Mr. P poops there and takes it back to itself. You get? So that's how you can visualize Kafka. Now the complicated part is that there are lots of sweet things that happen within the Kafka itself. You get? There's bucket, there's the bucket have buckets inside of the buckets. You get? So there's let me put okay, let's just take this one bucket as a single broker, because your Kafka will be referencing it as a cluster, and the cluster has brokers, which are instances of Kafka. That's how I would. But let's just deal with one broker now. So you have one broker, and those brokers are splitted into topics. Yeah, let's split them into topics. Split them into topics. Can have several topics. Okay, so you can have several topics, and then let's put something here. You can have like a lead. It is called, let's say, meta. Is meta let's say metadata, meta information about the cluster. It contains the information about the cluster. So whenever new brokers are coming, they come and study, okay, this is what this cluster is, this is where this partition, this is where this partition. Okay. I now know about it. Okay, let me just set it up. So they are split into topics, and those topics now can now be split into partitions. Are we following? Hello? Are we together?
Yes.
Okay, good.
Yeah.
So those topics can be splitted into partitions. So when a producer comes, it just handles whatever it's sending. It can be key. There's a key, but the key can be null. So I'm not going to go into that key discussion, so I don't deviate a bit. So there can be key to decide where to partition, or you just allow the Kafka decide where to store whatever it is storing. So the Kafka can then store that event somewhere. You get? Then the consumer now comes. So how the consumer picks it, now how it identify or locate it, the topic name, it uses topic name, the partition, and the offset. Yeah, the offset. Use the topic name to locate what it's looking for, and then the partition to get it. You get the offset. The offset is like index. You get the offset is like index. It's just another word for index. Let's put it that way. Where it's located, where it's seated. Okay, let me go back to the presentation. I just want us to see Kafka as a big bucket of logs. It's not something special. I mean, it's special. You get to appreciate what the guys did. Yeah. So send message to, like I've already in the presentation here. I've sent message to Kafka to forget after success and moves on with the life. That's the concept of decoupling. Yeah, it doesn't care whether the consumer is alive. It doesn't care. I don't care. Just have I sent to Kafka? Okay, good. Let me go and rest. Now, although there are complicated systems where you want your producer to actually, maybe it's your system is such that it's a stream of events that triggers another event because another event happens. You get another event was successful in certain ways. So you want to, if you are building such system, there are different ways to approach you knowing that the consumer has actually gotten an information. You can say, okay, you can do it by directional. So when a producer produces and sends and the consumer gets, then the consumer can now send back to Kafka so to confirm to the producer that it has gotten. But it's based on what you are building though. It depends on what you are building. All right. So let's move on. So like I said, I mentioned offset earlier. So there's the offset where those events are stored with index, you get index. Then it's append only log, so it's appends at the bottom. Yes, it appends at the. So as events comes in, they attach themselves to the bottom. So we have persistent storage. Messages are not deleted after consumption. Data persists in the disk. Yes. So that's where the concept of replayable comes in. Yeah, you can replay this event. Yeah. So even if there's a failure, when Kafka picks up, it will be able to replay that event. Yes. And that's the nature of Kafka. In fact, if Kafka goes down and there's an event somewhere that has not picked up, especially in the DLT, dead letter transfer, it will go there and first of all replay that event before it moves on. If it's replaced and see that it didn't work, to continue. If you shut down the Kafka again, it comes back up, it will first of all replay that event. Then if nobody picks it up, it continues its life. So it is going to retry a message forever as long as it's living and the message is there. So consumer tracked. Each consumer tracks its own offset position independently. And then the replayable event enables replay debugging and full event source matches. Oh man. Okay. Let me move fast. Okay, so let's just talk about terminologies now. I've been mentioning terms and yeah, let's talk about them. So broker is a single running instance of Kafka. Broker is an instance of Kafka, just as how your container is a running instance of an image. You get, so broker is a container. It's basically just another word for it. Broker is a container. Hello, can you hear me?
Yes,
Hello?
yes.
Hey,
Hello.
thank you very much. Yeah, okay. Okay, so Docker is container. For those of us that have done Docker, I believe we've done Docker. Yeah, I believe. So cluster, like I said, cluster is like group of those brokers. So that's cluster is the group of those brokers. So when you're working with a system, it will be, especially in terms of that horizontal scaling, it's not a single, you can have multiple brokers. So it's not just one broker, like you can have multiple brokers. That's why it's basically we want to refer to it as cluster, because you can have multiple brokers when you're running your Kafka. So when you introduce Kafka, then there's something called I think it's metadata attached to the cluster. Those new broker can read from and get information on what is already existing in the system. Yeah, so it's cluster. So the group of broker is called cluster, working broker. So topic, a name category for messages. You get producer writes to topic, consumer reads from them. You get so this topic is like a location in the Kafka. You get it's a category. It's one of the ways to locate message. You get when the producer sends, it sends to a topic. It sends to a topic. So a topic is actually a location in the Kafka. The topic is a location in the Kafka. You get, and that topic now cannot be broken into partitions. You get, so and then those partitions now have offsets inside of it. So like a bucket instead of a bucket instead of another bucket instead of another bucket. You get, so you have partitions, a shared slice of a topic. Like I said, a shared slice of a topic stores message in order, enables parallel processing and other stuff. So then we have leader. Now, let me just touch a little bit on the leader. This is where some things now look somehow complicated when you're working with Kafka. But the bottom line is that Kafka is a giant bucket of logs that streams those events for you. You get, so now I gave a story of what Promise Akene did, where he had his sister to store an information that he already has, but probably at some point something can happen to him, he can forget. Let's have a replica. So if Promise Akene is active forever, like it's active, we never will lose the message. The replica will not work. The replica will not come to. The replica will not have to do anything. Just as the replica will not have to do anything as long as Promise is active. You get. So partitions, you can have a partition 1 that has a replica, same partition 1 in another broker. So the replica exists in another broker. The replica of partition 1 exists in another broker, not the same broker now. Partition 1, the replica exists in another broker. So the replica contains is a carbon copy of what that partition 1 has, or what that partition 1 is. You get, it's a carbon copy of what that partition 1 is. Now, where the concept of leader now comes in is that, because now you would want to ask the question that if there's a replica across individual, let's say we have 3 brokers, and then there's a partition here, partition 1 exists here, partition 1 also exists in the second broker, and then partition 1 also exists. So how do we select where to pick from? Like I said, if Promise is active for life, they wouldn't have to ask the sister. You get, so even though he distributes the information across, let's say he has 5 sisters, they will not ask them as long as Promise is active. So this is where leader now comes in. Leader is a broker. A leader is a broker that is leading a particular partition. Let me come again. A leader is a broker that is leading a particular partition. So, like I said, you can have partition 1 across 3 brokers. So you have partition 1 here for same topic, same notes. We are talking about same topic because you have partition 1 for another topic, same topic. You have partition 1 for this topic in broker 1, and that same partition 1 in another broker and the third broker. So how do we now know where to pick from? Because we shouldn't be guessing. So there would always be a leading broker that leads that partition. So whenever a consumer is coming, he's looking for the leader, he's not looking for the replicas. Whenever a consumer is coming to consume information, he's looking for the leader of that partition, which is the broker. So it can be led by broker 1, and broker 1 is leading that partition. Okay, go to broker 1, pick your information. You don't care about those other ones. It will only care about those other ones if broker 1 is sick in the head or broker 1 is down for some reason. Yeah. Then that's where leadership will now be reassigned. So there's something called reassignment or redistribution. You get, so it can now reassign leadership. Kafka will now automatically reassign leadership to another broker, and then when the consumer comes in, it picks it up from there. So you see the durability and the portability of Kafka. So if one broker is down, it does not stop. It does not stop work because a replica already exists to pick the work up wherever it stops. Yeah. So that was the concept of partition leader replica. Good. So let's move on very fast. My time is spent. Okay. So partition as a replica. It's easier when I was studying it. So it's easy to want to conflict the two: partition, replica, partition, replica, partition, replica. Although they mean different things, like in terms of their English meaning. But again, I feel like it's a bit of something, then it's a bit of the other thing. You get. So partition is actually what makes for the scaling unit, for scaling. Yeah, like I said, I made, let me put a balance to what I said earlier about partition not being what will actually scale horizontally. Without extra broker, your partition will just be there. You get. But with extra broker, if there's no partition, that broker will just be there also. You get. If there's no extra partition for it to work on, it will just be there also. So partition is like the script for brokers to work with. You get, like the program that actually makes that gives life to the horizontal scaling when you bring in additional brokers. You get, but there must be additional brokers. Yes. So it's what makes for scaling. So then there's the replica. Replica is basically, like I've said, the sister of promise is backup for promise. Right? So replica is just basically backup units. So what makes for fault tolerance. Followers don't handle it all right. Yeah, they don't do that. That's why I say the consumer does not come to a replica. They don't do that. So they just make sure they have a exact replica of what the leading partition or the leading. Yeah, let's just call it the leading partition, but it's actually broker as the leader. Yeah. So let's move on. So how Kafka actually scales, like I said, no horizontal scale. So you can have, like I said, you can have 3 partitions with one broker. That is not horizontal scaling. It's not. All partition on one machine, no load distribution. It's still on one. You can spread it, but it's still one machine. You can spread it. It's still one machine. It's similar to, let me say, sharding. Database sharding or whatever. As long as it's one system you're splitting, it's just like you splitting your screen into 4 different screens does not make it any wider. You get, like I just split the screen, it does not make it any wider. I'll just have the same screen, and even the stress level will be for that equivalent for that I split it. So the next thing is true horizontal scaling. True horizontal scaling is actually when you add broker to your partitions. So like I said, broker 1 handles partition 0, broker 2 handles partition 1, and this is what you call distribution. Yeah. So yeah, are we following? Before I move on, are we following? Are we together? Are we together?
Yes, we are.
Okay, thank you very much. Let me continue. So RabbitMQ versus Kafka. I think I'll give you guys this one as personal exploits. You should go and exploit this one. But I'll drop this slide. So based on what I've explained so far, you should grab what's the difference to Kafka and RabbitMQ. So I'll not go deep into this. So good. Let's jump into code. So we have Kafka is a running instance, right? So you know you need something. You need Kafka running. Kafka is an intermediary. It's not a code something that you know. Kafka is an entity itself. Like Kafka is a physical addition to your code base. You get there was a time we're trying to deploy an application on free and this GSQ Amazon version. I was trying to deploy, and then I had to do a Docker compose. Yeah, but the Docker compose had to have like the I have to the server has to have like Docker inside of it. So I have to include Docker then before you can even do Docker compose or Docker to pull images and other stuff. So by the time I installed Docker on the server, I had Docker on the server. When I tried to run my Docker compose, because Docker compose now we pull my code base, the Kafka image, and other stuff. Once I just run that compose right there, the server just froze. Just froze. And why? Not that Amazon is bad, or just I'm using free version. So it takes space. It's an entity. The Kafka itself is an entity, so it comes in space. Let me see. Let me show you my Docker. Shut. Let me share my entire screen. I don't think I can do that. Okay. But the code, when you have your Docker installed, when you have your Docker installed, you want to do Docker pull Apache Kafka latest. This for you to pull the image into your Docker, your local Docker desktop. And then you want to do this to run the container. So you give the container a name. Normally, if you don't specify a name, you just give it a random name. So you want to do this. So once you have this on your system, you cannot go ahead with this code base. Let's start from the producer. So, Kafka is 4 microservices. I really do not see why you'd be using Kafka for a monolithic application. I'm trying to see why, but I cannot see it. But if somebody can see why, I think the floor is open for the person to show me what they saw. So let me go to man. I have to share my screen. Okay, let's go here. Let's publish first of all. Let me share my screen. Go here. Stop sharing. Okay, let me share my. Okay, let me share this one. Okay, can we see my producer code base? Hello? Okay, good. Before I even do that, let me share on that. Hello. Okay, can we see my Docker desktop? Confirm you can see my Docker desktop, which. Okay, good. So you can see I have a container running. So you can see your Apache Kafka, it takes space. Yep, takes space. So you can see the Apache Kafka running. And, you can shut it down here. You can do your work manually. It doesn't have to be a command line anything. You can do it manually. And you can also do it. You can also do it from the command line. So let me share my code base again. I just want to talk from that. So we'll have the same view. Hey. So there are 2 services. So let me just show the producer first. So the producer, we have just simple basic code. We have the demo publisher, we have the producer. Okay, we have the demo publisher application, we have the producer service, we have the publish controller, we have my swagger. I will always include swagger. I don't like stress. I don't like touching postman. Okay, so let's look at the producer service. Just basic something, just a basic setup. So it's not as complicated as having a QA comes to the code base, yes. Except doing some magic. So there's the Kafka template, and then takes your message and sends. So let us look at some key properties in the application of properties. Let me just speak about them a little. So this I showed you my Docker. So you saw the port it was running on. It was 1992. Now the ports my Docker was running on. So like I told you, I said the producer does not really have much, does not really care for much. You get. So the only two things you add, the only things you need is the demo topic, the topic name. Like I said, the producer is going to be sending to a topic. So you just need the topic, and then you need these things. Now watch notes so that you don't make mistake in certain things. Now we have the key serializer, we have the value serializer. Okay. The key, like I said earlier, I said the key is nullable. The key is for you, the producer, based on what you are configuring. Okay, do you want it to be routed in such way? Do you want it to be routed in this way? You get, or do you just want Kafka to decide where to route it, which partitions to always use? You get. So the key you can do like key hashing, something like that. Is it keying? I think it's keying, where you hash the key. You do a module for the hash of a particular key. You can use your email as the key. Then it always routes to that particular module. So if the value of the hash is, let's say, 10, and the module that you're calculating with is, let's say, 4, so it will always be routing to 10. The remainder is 2, so it will always be routing to partition 2. You get, if you are using keying format. You get. So that's where that this key comes in, but it can be null. It's optional. It's optional. Yeah. But I'm not saying this year is null. I'm saying when you are sending your message, if we check let me see the producer service. We have these two things. Let's send. We have the topic, we have the message. Send to Kafka. We have the topic, we have the okay. Oh, I didn't even specify key here. So you can specify a key. This is just using topic and key. So I didn't specify key here. So if I specify key, I would have placed it here in the middle somewhere. You get. So let's go back to this. So what this does is, like I said earlier, I said the Kafka does not store it as JSON or anything. It stores it as bytes, so string of bytes. So it serializes whatever you are bringing to it, which can be string, or so this thing can either be string or we call it JSON. Can be JSON serializer or string serializer. Okay. So if you are sending a string, it uses string serializer to serialize it into bytes, so strings of bytes. You get, in the Kafka, that's how it is stored inside of the belly of Kafka. You get. So what you encounter mostly when you are working in a robust system, or in fact even in basic system, because what you are going to be storing in your Kafka, you are not going to be storing just names. It's probably an event that has other details. So it will be like your Java object. Your Java object has email, it has different fields. So what you are going to be storing is that. So what you want to do is, you first of all deserialize it. You first of all serialize it into JSON string. You will not see that in this particular this thing. There's no, that setup doesn't exist here. So what you want to first of all do is you first of all serialize, convert your Java object into JSON string, and then you now convert it. You now convert that JSON string Now this with this particular stuff field here for your value, because that's your value, it now converts it into bits that can now sit inside of the Kafka bucket. Yeah. So that's that for your producer. If I run this code, let me see. Let me go. The code is running. I wonder why the code is taking time to run. My Kafka is loaded. Okay, it is done. Give me a minute. Okay. I will open my Swagger now. Service. Let me discard this. Okay, let me go to Swagger. It is running on port 88C. Stop sharing. What port is it running on? Oh. Yeah, it didn't run. Oh, this one. How I put it up value. Oh, sorry. I converted this to convert it to string. Sorry about that. Let me share my one. Okay. What am I sharing? Okay. Share. So let me just publish this. Let's see. New message for me. Application. New application. Oh Lord. Yeah, so new message sent from the application. So if you check my producer, you see new message from the user. So it has been published now. This is the concept of decoupling. I'm not running the consuming service yet. I'm not, but the publisher was able to send to Kafka. Now, anytime the consumer service comes up, it should pick it up. So let me just give me a minute. Let me set up my consumer service. Let me just set it up. Wrap up in a minute. Okay, I think this should let's see this. Okay. I think I'm good here. This is all I need, right? Give me a minute. Let's see. Fish. There. That's all. So let me run my publishing now. So let me just share my screen. So you can see my publisher. Yeah. Okay, good. Can see my calendar. Just a minor setup so that we'll see what's going on. So with this, once I publish, now the setup is quite different from the producer. So for this, yes, we do have our JSON. We have the string deserializer. We have the topic, just as we do on this thing. But now here there's two additional fields. So your consumer have groups. I'll not be going deep into that. It has group, and then there's the earliest. This is telling it how to fetch whenever the assigned offsets for a particular producer or consumer coming in is consumer coming in. We don't have like a previous prior information, or it is cleared. But it is how you should go about it. Look for the earliest. Look for the earliest offset. So let's look. Let me run this. Let me just run it from the application itself. Oh, it's coming up. So once it comes up, it just picks up. It just picks up what we have published to Kafka. That's how it should be. Unless anyone form around this night. So, yeah, that's how it should be. If we form around, guys, we'll continue the teaching. But yeah, what we'll see down here on our terminal, we'll see what it published. So you see, join, blah blah blah. Fail to join. See, unless anyone form around this night. I just know. I'm calling. Demo topic, okay? Why are you not picking it up? Okay, good. Can we see? Hello, can we see the magic? Hello, are we together? Is there anybody here? Okay, good. You can see now that even though I published a while back, as I start up I just start up my consumer, it was able to go to the Kafka and pick up the message that is meant for that topic. And this is what you're seeing here. This is the first one I tried before the application, before running, before we start the session. And this is the one I just did. Yeah. So that's the magic of Kafka. So enough of the practical. So let's go back to let me come back to our slide. Let's conclude. Okay, so we've seen how to start up the Kafka container. These are the two commands. There's nothing magical. These are the two commands you need. These are the two commands. You start up your Kafka on your Docker. Once you have your Docker, you get those few codes that we built. That's how there's something called first principles for everything. You got this the basic, this is the needed foundation. Even if you are going to do the most complicated thing on Kafka, this is where it will start from. There will always be this foundation. So this is where it starts from. From there, you do the most complicated thing you want to do on Kafka. Yeah, but this is always the fundamental. You always do this. Like, it doesn't matter what complication you want to do, even though you want to abstract it in such a way that you will not see that it exists. That thing will still be the foundation. This setup is already. So let's summarize. So Kafka is distributed log system, messages are immutable, blah blah blah. There we have the pub sub model, the couple producer. We have the partition states works across clusters. We have the true horizontal scaling happens when partitions are distributed across broker, not just from one broker. Kafka excel at event streaming, having them be better suited for task queuing. Task queuing pattern. Those do this first before you do this first. So, but Kafka is more robust. Yeah. So finally, who am I? This is me. And I know some of us will not want to believe this, but yeah, that's just me. I can't help it. So any question? It is exactly 9:30. Thank you, Gooseberry. Okay. I think everybody has slept off. Oh yeah, you know what? Somebody should drop their accounts. Let me transfer. Okay. Gloria, you can wrap up. Thank you very much for listening to me. I know there are senior developers here. They are just clapping like, what is this boy saying? But thank you for listening to me. Gloria, are you there?
Yeah. Yeah. So thank you so much for the section. Please, do you have any questions, or is there something you learned that you just want to comment on? So none of us learned anything new. Can you hear me? No, Rosie, I'm not saying anything. Someone else.
Thank you very much.
I will not add that. Someone else. But can anyone hear me? Because I think my network is a bit acting up. All right. So in a sense of that, we will be in cost of you asked the question after the meeting. Well, it's already 2 minutes late. Drop the question on the admin group. Yeah. So, or probably on the main group so other persons can still learn from it. So thank you so much for joining. I'm so sorry. I'm not being biased, right? Yeah, it's just that I'm trying to work with time. I'm so sorry. I'm so sorry. So thank you everyone for joining. Don't worry. I'll reach out to you later. So, okay, Rose, Samuel, and I can stay behind. But thank you so much for joining, everyone. And please, the event on Saturday, the event will be shouting since last month. It's happening this Saturday. Please do well to share the flyer and reach out to your friends that you feel they can benefit from that section. So do enjoy the rest of your night. If in case you had network issue in course of the section, the video will be live by 1 a.m. tomorrow. So you can go back and relearn. So do have a lovely night, everyone. Good night.
Good night, everyone.